Thank you for connecting with us live on FK Academy channel. We are going to prepare for the exams by going through these questions. Further mathematics. The equation of a curve is given by y equal to x over x minus 1, x not equal to 1. We have to find the gradient of the curve at x equals 0 and x equal 3. So before we begin, you can support this channel by sharing this video, this live stream. Thank you for sharing. So the A part, let's see how we can do that. So the equation given to us is y equal to x all over x minus 1, and we can find the gradient of the curve using dy dx. So dy dx will give us the gradient function. So we are going to use the quotient rule over here. V du dx minus u dv dx all over v squared. That's the quotient rule. So our u is 2x. U is equal to 2x. So the u dx will be equal to 2. Then our v will be equal to x minus 1. So dv dx will be equal to 1. So we fix in these expressions. V is x minus 1 times du dx, which is 2. So we have dy dx is equal to v, which is x minus 1, du dx, which is 2, minus u is 2x, u dv dx is 1, so 2x times 1, so u is 2x, dv dx is 1, all over v squared. V is x minus 1, so all over x minus 1 squared. So this will give us 2x when we expand. 2 times x is 2x times negative 1. So we have negative 2 minus 2x all over x minus 1 all squared. So we are going to obtain 2x minus 2x is 0. So we obtain negative 2 over x minus 1 all squared. So this is the gradient function. Dy dx is equal to negative 2 over x minus 1 all squared. So the gradient of this curve at x equals 0, we have to substitute x equals 0. Then the gradient of this curve at x equals 3, we substitute x equals 3 into dy dx. So recall that we found dy dx to be negative 2 over x minus 1 squared. So dy dx is equal to negative 2 over x minus 1 all squared. So at x equal 0, dy dx will be equal to negative 2 over 0 minus 1 all squared. and that will give us negative 2 over negative 1 squared, which is 1, and that will give us negative 2. Then at x equal 3, dy dx will be equal to negative 2 over 3 minus 1 all squared, which is negative 2 over 2 squared, which is 4, and that will give us negative 1 over 2. Now we are asked to, so we are done with the A part of the question. The B part says we should find the equation of the tangents to the curve at x equals 0. So the equation of the tangent to the curve at x equals 0. So at x equals 0, we found the gradient to be, so bi at x equals 0, the gradient dy dx is equal to negative 2. That is our gradient m. Now we need a point and a gradient to find the equation of the line, which is a tangent. The tangent is a straight line. So we know that y equal 2x over x minus 1 is the curve given to us. So at x equals 0, y will be equal to 2 times 0 over 0 minus 1. So y will be equal to 2 times 0 is 0 over 0 minus 1, which is negative 1, and that will give us 0. So the point is 0, 0, which is the origin, and the gradient is negative 2. So the equation of a line that goes through the origin with a gradient m is given by y equal mx, and the m here is negative 2. So the equation of the tangent is y equal negative 2x. So the equation of the tangent at x equal 0, the equation of the tangent to this curve at x equals 0 is y equal negative 2x. Then the equation of the normal to the curve at x equal 3. So remember, at x equal 3, the gradient was negative 1 over 2. At x equal 3, the gradient is negative 1 over 2. So that is the gradient of the tangent. So bii at x equal 3, dy dx was negative 1 over 2. Now this is the gradient of the tangent. By this time we want the equation of the normal, so we have to find the gradient of the normal. Note that the gradient of the normal, m1, times the gradient of the tangent, m2, will be equal to negative 1. So if the gradient of the normal, m1, is negative 1 over 2, when you multiply it by, and if the gradient of the tangent is negative 1 over 2, when you multiply it by gradient of the normal, we should get negative 1. So it means that m2 will be equal to, multiply through by negative 2, negative 1 times negative 2, which is 2. So the equation of the line with gradients 2, we need a point now. So a point on this curve at x equal 3. So when x is equal to 3, y will be equal to 2x over x minus 1. So 2 times 3 over 3 minus 1. That will give us 2 times 3 over 2. And that will give us 3. So the point is 3, 3. And the gradient is, in this case, m is 2. So m is 2. We found it here. And we found the point to be 3, 3. So the equation of a line going through the point 3, 3 with gradient m equal 2 is given by y minus y1 equal m into bracket x minus x1. So this is our x1 and this is our y1. So that will give us y minus y1, which is 3, is equal to m2 into bracket x minus 3. So we have y minus 3 will be equal to 2x minus 6. So y will be equal to 2x minus 6 plus 3, and that will give us negative 3. So that is the equation of the normal to the curve at x equal 3. So let's wrap up. Over here at x equal 2, we found a gradient to be equal to negative 2. Then at x equal 3, we found a gradient to be equal to negative 1 over 2. Then the equation of the tangent at x equals 0, we found that to be equal to y equal negative 2x. Then at x equal 3, the equation of the normal was y equal 2x minus 3. Thank you for joining us on this live stream. We'll continue, so keep coming back for more. Thank you for connecting with us live on FK Academy channel. We are going to prepare for the exams by going through these questions. Further mathematics. The equation of a curve is given by y equal to x over x minus 1. X not